video explains why 0 factorial is defined to equal 1. Understanding this convention is essential for combinatorics, permutations, and series formulas you'll see throughout algebra and calculus. You'll learn to justify this definition using the recursive factorial rule, the empty product principle, and combinatorial reasoning. We'll use the recursive definition of factorial. Plugging in n equals 1 forces 0 factorial to equal 1. We'll also see why the empty product convention agrees. Let's work through it on the diagram. 0 factorial equals 1. That looks strange. Multiplying no numbers should give 0, right? Students often guess 0 factorial is 0 because there's nothing to multiply. But the recursive pattern of factorials forces a different answer. Goal: prove that 0 factorial equals 1 using the recursive definition. Step 1. Start from the recursive definition of factorial. The recursive rule says n factorial equals n times n minus 1 factorial. For example, 4 factorial is 4 times 3 factorial, which gives 24. Now set n equal to 1 in the recursive rule. 1 factorial equals 1 times 0 factorial. But we know 1 factorial is 1. Therefore, 0 factorial must equal 1. Let's also see this from the divide by n pattern. Step 2. Rearranging the recursion. Each previous factorial equals the next one divided by n. 3 factorial is 4 factorial divided by 4, giving 6. Continuing the pattern down to 1 factorial equals 1. One more step down, 0 factorial equals 1 factorial divided by 1, which is 1. The pattern confirms it. Whenever a recursive definition needs a base case, plug in the smallest value and solve. Substituting n equals 1 into the factorial recursion forces 0 factorial to equal 1. 0 factorial equals 1. Not a strange convention, a necessary consequence of the pattern.